Good afternoon, everyone. Today, our topic is nucleophilic substitution versus elimination reactions. So, we have already discussed about nucleophilic substitution reactions in our previous lectures, but today I will give some highlights about nucleophilic substitution reaction. So, what are nucleophilic substitution reactions? In nucleophilic substitution reaction, there is replacement of one group with another group. As look at the example number 1. Here, the substrate we have been using is tertiary butyl bromide, and it is undergoing SN2 mechanism. In SN2 mechanism, first of all, there is formation of carbocation as intermediate. Then, in second step, nucleophile attacks on this carbocation. Thus form the final product, tertiary butyl alcohol. So this is the SN2 mechanism. Then this is one of the mechanism of nucleophilic substitution reaction. The another one is SN1 mechanism. In SN1 mechanism, the substrate is methyl bromide, as methyl bromide is more subjected toward SN1 mechanism. In this, the nucleophile is also OH negative. In this reaction, the first nucleophile attack on this carbon, and there is formation of a transition state. Look at this transition state. In transition state, one bond is forming, another bond is breaking. So here the carbon have 5 bonds, so carbon is unstable in this molecule. So there is a double dagger which represent the transition state, and then we are getting the final product, methanol. So this was the all about nucleophilic substitution reaction. We have been seeing in this, the bromine group is replaced by the OH group, and this is also true in case of the first example, bromine group is replaced by the OH group. So this is the nucleophilic substitution reactions. So there are some common leaving groups. Either instead of bromine, we can also use chlorine, iodine as well, OTS, methyl tolulyl sulfoxide, methyl sulfoxide, trifluoromethyl sulfoxide. So these are some common leaving groups. These can also be used instead of bromine. Then moving to our main part, that is elimination reaction. Elimination reactions. So what is the meaning of elimination? Elimination means loss of groups. In elimination reaction, the groups are lost and leads to the formation of pi bond. Look at this example. This is ethyl bromide. Ethyl bromide was subjected to undergo elimination reaction and thus forming alkene as final product. In this, both hydrogen and bromine both are lost from the reaction. So it is called as elimination reaction. But in substitution, one group is replaced with another group. In this, there is nothing added, nothing replaced. In this, the groups are removed. So this is named as elimination reaction. So in elimination reaction, there is also a requirement, there should be presence of base. So this is another example. Here, base will abstract the proton from here, and further the electron will shift to this carbon and carbon double bond, and this, it facilitates the removal of bromine. That is the leaving group, and thus forming double bond between this carbon. No, the carbon next to functional group is known as alpha carbon. So this is your alpha carbon. This is the alpha carbon. So always in elimination reaction, the H is abstracted from alpha carbon. Okay. So these are some kind of elimination reactions. So, but what is our main topic? We have nucleophilic substitution versus elimination reactions. Good. So you can see here we have chosen reactant primary alkyl halide. But in case of nucleophilic substitution reactions, we are also choosing reactant. That is, in this case, you can see, just wait a second. Here, the reactant chosen is tertiary bromide. See, tertiary alkyl halide. This is primary alkyl halide. In elimination, we are also using primary alkyl halide. So how can we say what kind of reaction will undergo elimination and nucleophilic substitution reaction? So this is our main concern. So what conditions prefers elimination reaction over substitution reactions? So for the elimination reactions, there are certain conditions. In this, nucleophiles should be strong bases. The nucleophiles which are strong bases, it prefers elimination reactions. The second one is nucleophiles must be bulky. If nucleophile is bulky, then it is also preferring elimination reaction over substitution reaction. Third one is if the reaction is carried out under high temperatures, then it will also form the alkene, which is the major product of elimination reaction. So we will discuss these three factors in detail, how these factors favors elimination reactions. Let's see. First is in case of strong bases, if there is a strong base. So I have taken the example of weak base as well as a strong base. First, considering the example of weak base, this is tertiary butyl bromide. This is tertiary alkyl halide. You can easily say tertiary alkyl halide. So here the nucleophile used is ethanol. Ethanol is a nucleophile. Look at the product. It is a substituted product. Substituted product. Okay. So it is undergoing SN1 mechanism. First of all, here leaving group is removed. Thus, it is forming carbocation as intermediate. Here, carbocation is the intermediate. Now, in second step, what will happen? This oxygen from ethanol will attack on this carbon, and the ethanol will be deprotonated, and this form led to the formation of final product. Here, so here ethanol is weak base. It only undergo substitution reaction. So substitution, in the case of substitution, it can replace one group. But here, what is the role of base? The function of base is to accept H positive. Okay. Either you can use other term, it abstract H positive because base is electron rich in nature. Nucleophile is also electron rich in nature. Nucleophile is also electron rich in nature. But nucleophile it attacks on the carbon, but base abstracts the hydrogen. So this is the basic difference between a nucleophile and a base. If nucleophile is a strong base, then it will lead to elimination. But here we have used weak base, that is ethanol, means here it is acting as nucleophile. What is the value of pK value of protonated ethanol, that is -7. So there are several molecules of ethanol. There is another molecule of ethanol. So one of the molecule of ethanol get protonated itself. Okay, the another will also get protonated. So here the pK of molecule is less. So that's why it is acting as a weak base. See, we have conducted the same reaction using strong base, in which the base is ethoxide ion. Ethoxide ion. There is the negative charge on the oxygen. So the product form here is the alkene. It is favoring elimination. Why this is favoring elimination? Look at this reactant. I have expanded this reactant. Both are the same, but I have represented here in the expanded form. Here, ethoxide will abstract the proton from here, because ethoxide here is a base. Base will always abstract H positive. When it will abstract H positive, it further lead to the formation of double bond between these two carbon and facilitates the removal of halogen, that as Cl negative. This is alpha carbon. So there is formation of double bond between alpha carbon and this carbon. You can number it as ones to remove confusion. 1 and alpha carbon. So there is a formation of a double bond. So her first condition is nucleophile should be a strong base to favor elimination. Here, what is the pK value of ethoxide ion? That is 16, means it is acting as a strong base. Let us take another example which favors elimination. This is also the case of strong base. So here I am using primary alkyl halide, that is ethyl bromide. It was allowed to react with aqueous QH as well as with alcoholic QH. So here see the difference between reagent. Here we are using in first case aqueous QH, in second case alcoholic QH. And look at also the products obtained from aqueous QH. From aqueous QH we are getting substituted product, that is ethanol. But in case of alcoholic KOH, we are getting eliminated product, that is alkene. Okay, so why this all is happening? So what is the difference between both these two reagents? You can, as substrate is same, that is ethyl bromide, but the products are different. It depends on the reagent. In case of aqueous KOH, what is happening? QH, it is a potassium hydroxide. We know it comes in the form of pellets. Solid pellets means it's solid substances. When it is dissolved in water, what happens? It is ionized and leads to the formation of K positive and OH negative. Further, it gets solvated, means it is surrounded by the opposite charges of water molecule. Here OH is negative charge, then it will be surrounded by the H of water, OH, H, OH, means this OH negative is stabilized. So similarly, K positive is also stabilized. These both get solvated. It acts as nucleophile. It is not a strong base because of solvation. Due to solvation, the electron density on this oxygen decreases. I have discussed already the concept of solvation in nucleophilic substitution reaction. See, in case of alcoholic QH, that QH is dissolved in alcohol, ethanol. So what happened? Positive, negative. As we know, there is ionic bond in QH. This OH negative will abstract the proton from here and this form C2H5O negative. K positive plus H2O. There is formation of a base, that is potassium ethoxide. Potassium ethoxide. Potassium ethoxide. So this potassium, but basically this potassium ethoxide is a strong base. There is no stabilization of this intermediate as compared to above mentioned QH in water. So here in this case C2HO5 negative is a strong base. So what base will do? Just represent the reactant in this form, C2H5O negative. It will extract the proton from here, thus further it facilitate the removal of Br negative and led to the formation of alkene. Yeah, so this is a basic difference. If we use strong bases, then elimination is preferred. Clear? So coming to second factor, in second factors, we said nucleophile must be bulky. If nucleophiles are bulky in nature, then it prefers to undergo elimination reactions. Let us take the example here. This is butyl bromide and it undergoes substitution reaction. This is an example of substitution reaction. See, the product here is substituted product, alcohol is forming, but in second case, substrate in both cases is same, that is butyl bromide. In second case, we have chosen nucleophile, that is tert butoxide. You can say tert potassium butoxide also. Tert potassium. Tert represent tertiary. See, these methyl groups attached to oxygen. This carbon is tertiary. 1, 2, 3. So this is tertiary butyl. Okay. So the tert butoxide. Okay. Tertiary potassium butoxide here is a nucleophile which is bulky. Bulky means which produces steric hindrance. If it is producing steric hindrance, then it do not act as nucleophile. It lowers the nucleophilicity. If we are choosing bulky molecules, it causing steric hindrance and decreasing its nucleophilicity. So here it is acting as a base. See, this is abstracting the alpha hydrogen and it facilitates the formation of double bond and the removal of bromine as Br negative. So it is forming alkene as the final product. So this is the second condition. Nucleophile should be bulky in nature. Third one is high temperature. How high temperature prefers elimination reactions over substitution reactions? In both cases, we have taken primary bromide, alkyl bromide. In this, QH is taken as base. In this, you can take also tertiary butyl butoxide. Okay. So in first case, there is formation of one product and one byproduct. Okay. One product and one byproduct. So there is total formation of two products in case of substitution. But in second case, that is the case of elimination, what we have been observing, it was observed that there is formation of one product and two byproducts. Okay, as H is abstracted from here, and there is formation of double bond. So K, Br, and this H will attach to this oxygen, thus forming butanol. Okay, so this is also tertiary butanol, that is CH3, CH3, CH3OH. This is tertiary butanol. This is one of our byproduct in these reactions. So in case of elimination, there is formation of three products. If we take the concept of entropy, so entropy means degree of randomness. Degree of randomness means in which there is more disorientation in which molecules are not oriented, means there is disarrangement of molecules. Okay, that term is known as entropy. If I am showing the pattern like this, there are four molecules in this pattern. On other side, molecules are like this. There is no orientation. Okay, these are in oriented manner, these are in unoriented manner. Then which case has more entropy? In which there are more number of molecules and in which there is no orientation of molecules, that has more entropy. Similarly, in case of elimination reactions, the entropy increases. If entropy is increases, see this equation, delta G gives free energy, delta H enthalpy, T is the temperature, and delta S is the entropy. If entropy is increasing, then delta G will be more negative in case of elimination reactions. If delta G is more negative in case of elimination reaction, then what happen? Obviously, it will favor elimination reaction. As we have been also increasing the temperature, this whole factor increases. As this whole factor increases, then delta G will be more negative in case of elimination reaction. So it is clear from this point, high temperature led to elimination reaction. So these, in summary, these are the three factors which drives the fate of reaction towards elimination reaction instead of nucleophilic substitution reaction. Because same reactant can undergo nucleophilic reaction as well as elimination reaction, but difference in the nucleophiles are the conditions we have been providing. Next is in our previous top lectures, we have discussed the mechanism of nucleophilic substitution reactions in details. These are of two types, SN1 and SN2. Okay. Similarly, elimination reactions also proceed via different mechanism. The first one is E1, second one is E2, third one is E1cB. Here there is no subscript or superscript used. Here C is the lowercase letter and B is the uppercase letter. So it is written like here. So if come to the E1, E means elimination, 1 means unimolecular. E means elimination, 2 means bimolecular. E elimination, 1 means unimolecular, C means conjugate base. So we will discuss this mechanism in details. If coming to E1, what is going on in E1? In this, the rate of reaction depends on only the one substrate. So that's why we use term unimolecular. Okay. So basically here, what is a substrate? That is the alkyl halide. This is a reactant. This is alpha carbon. Okay. So what happens in this mechanism? First of all, leaving group is removed. Leaving group will be removed. It will lead to the formation of carbocation as intermediate. In second step, there is deprotonation of deprotonation by base, means proton is abstracted by a base and there is formation of double bond and forming alkene as a product. So we have to remember the points, these points. First is removal of leaving group, another is abstraction of proton. It is a two-step mechanism. Okay. Similarly, like SN1. In SN1, it is also two-step mechanism. In this, there is also formation of carbocation, but remember that this is the nucleophilic substitution. Here is we are doing elimination. So in this, there will be elimination. Okay. So the next is E2 mechanism. E2 elimination bimolecular. In this, the rate of reaction depends on both base as well as non-alkyl halide. Okay. Then what is happening in E2? In this, the proton is abstracted along with the removal of halogen. Both the steps are occurring simultaneous. Here we are using terms simultaneous. So loss of leaving group is simultaneous with the removal of the proton by base. So forming alkene as final product. This mechanism also contains one step similarly as SN2. Okay. 2 here we are using because the rate of reaction depends on both of these reactant base as well as on the concentration of base and the reactant, but both the groups are removed simultaneously. So in this step you have to remember this one. This is the basic difference between E1 and E2. Okay. The third one is E1cB. E1cB, it also seems like E1 mechanism. It seems like E1 mechanism. It also follows the mechanism which contains two steps like E1. Okay. So what kind of reactant undergo E1 mechanism? Let me explain. The carbonyl groups in which leaving group is present at beta position, those group will undergo E1cB mechanism. See, this is the carbonyl group over here, and this is alpha carbon, and the carbon next to alpha carbon is known as beta carbon. So the halogen group is present at this beta carbon. In this mechanism, the first step is the proton will be abstracted from alpha carbon of starting material. So this is our starting material. From here, proton will be abstracted. So what will happen? Let me draw the structure. CH3, C double bond O, negative charge upon this carbon, X, R1, R2. So there is formation of anion, okay? But further this anion is stabilized, it undergo resonance, thus forming another intermediate, that is enolate. Enolate. When there is double bond between carbon and single bond between carbon and oxygen acquires negative charge. This is known as enolate. En is used for double bond, enolate. Enolate. So enolate is a stabilized intermediate. Stabilized intermediate. So first step is abstraction of base. Oh, sorry, abstraction of H positive by base. Clear? The second step is removal of leaving group. From here, the leaving group will be removed. But which facilitates removal of leaving group? This enolate anion facilitates the removal of leaving group. Further, the negative charge on this oxygen will show resonance again. It will, these electron will shifted to this carbon, and this the double bond between this carbon and this one also gets shifted and facilitates the removal of halogen. Let me draw it more clearly. I would like to remove this one. See, CH3, CO negative, just showing from here. There is electromagnetic shift between carbon and oxygen, and double bond C, CX, R1, R2. This is alpha carbon and this is beta carbon. Then as this enolate is stabilizing the whole molecule, then it will undergo resonance and electrons shift back towards this carbon, and the double bond is shifted to the adjacent carbon and it facilitates the removal of halogen minus X negative. So there is formation of double bond. So this is the E1cB. E1cB. What was happening in E1? In E1, first of all, there is removal of halogen. I'm using some another marker to distinguish, okay? Because in E1, halogen was removed. First is removal of halogen, then second was abstraction of H positive. But E1cB, first step is abstraction of H positive, and the second step is removal of halogen. Okay, so this is a major difference. So remember these all steps. Another one, here we are using CB, conjugate base. So why we are using here conjugate base? Okay, so in first step, proton is abstracted from the starting material. You can see this halogen is removed from this intermediate. Okay, this is a conjugate base of starting material. That's why this is named as E1cP. Proton is abstracted from alpha carbon of starting material and the leaving group is removed from its conjugate base. When leaving group is removed from its conjugate base, those mechanisms are known as E1cP. Clear? So this all is the difference between E1, E2 and E1cB. E2 is one step mechanism. In this, both H positive and leaving group are removed simultaneously. Clear? Okay. Mm, look, there is another point also. As I have discussed three mechanisms E1, E2, E1cB. So we have to identify what kind of reactant undergo these mechanisms, either E1, E2 or E1cB. It depends upon the nature of substrate, whether nature of living group, nature of nucleophile, and nature of solvent. If we are using polar protic solvent or aprotic solvent, these all factor decides either it will follow E1, E2, or E1cB. Clear? So we will discuss these factors in next lecture, but now we will try some examples of nucleophilic substitution reaction and elimination reaction, in which reaction the nucleophilic substitution will occur or elimination is favored. Going to next slide. See, first case. This is 1, 2, 3, 4. Butane 2-ol. It is subjected to react with nitric acid, that is aqueous nitric acid, means this is not concentrated, but in the presence of high temperature. When we use this triangle, this represent temperature, means we are also supplying particular temperature. Okay, so we have to guess whether it will undergo substitution reaction or elimination. So just check the condition. Here temperature is used. So if high temperature is used, we will prefer elimination reaction. So the final product will be elimination product. CH3, CH3. Okay. This will be the final product. The H from here and the OH from here will be lost. So OH negative or OH can also act as leaving group. Okay, so this is the example of elimination reaction because here temperature is used. If the second one is 1, 2, 3, propyl chloride. Propyl chloride, uh, it this reaction was carried out under the condition of temperature as well as here reagent is used as aqueous NaOH. So which is the preferred product in this reaction? In this reaction, there is also formation of alkene because here we are using temperature. Okay, so we have to look at the all the factors, reactant, temperature conditions, reagent, whether it is bulky or it is simple in nature. So look, in both the reaction there is a symbol of temperature, so it will undergo elimination reaction. Next, the third one, it is similar like second reaction. Okay, but in this case only aqueous nucleophile is used. You can see here, you can also take NaOH in this case. Okay, so the substrate is different. This is the primary and this is the secondary bromide, cyclopentyl bromide. But look at the reaction conditions. There is no symbol of temperature. So in this case, we will get the substituted product. There is no temperature is used. As well, the reagent is not bulky. Reagent is simple. So it is not causing any kind of steric hindrance. The next fourth example, sodium ethoxide. We have done before this lecture. In this, we have done in this lecture. This ethoxide is a strong base. Strong base. What would it lead to? It would lead to elimination. So the product will be eliminated product plus HCl. Okay. Sorry. NaCl plus CH3, CH2, OH. These are the byproducts. Okay. So this is the reaction. We have to prefer elimination reaction. For elimination reaction, which is more suitable nucleophile? The nucleophile which will be strongly basic in nature will act as nucleophile in this elimination reaction. Okay, so just check, this is KCN, K positive, CN negative, this is ionic in nature. Okay, AgNO2, there is, it is covalent in nature. Okay, this is also covalent in nature. There is covalent bond between silver and oxygen, there is covalent bond between silver and nitrogen. Okay, but this is not bulky, so this is bulky as compared to first one, so second option is a good to conduct elimination reaction. Potassium ethoxide, the base will be used. Okay, let discuss another example. Hmm. Yes, we have been using primary alcohol, primary alkyl halide, secondary alkyl halide, tertiary alkyl halide, and the requirement is we need the substituted product using ethanol. Ethanol is the another reagent. So out of these three reactants, which would prefer more easily to give substituted product? This is our main question. So in this, primary alkyl halide will prefer easily the substituted product. Okay, because there is no bulkiness, there is no steric hindrance in reactant as well. So if there is no steric hindrance, it will prefer to undergo substitution reaction. The tertiary here will not prefer to undergo substitution reaction, only under SN2 mechanism. Okay, in SN2 mechanism, it will not undergo substitution reaction. It would like to prefer elimination reaction. Yeah. So it also depends on the nature of reactant. The next one is hmm, so this is the reactant and this is the final product. Look at the reactant and the final product. This is primary alkyl halide and this is alkene. Alkene is formed in the case of elimination. Okay. So what are the conditions which leads to this elimination? First is room temperature and above. Second is negative temperature, means less than 0 degrees Celsius. Freezing point of water means 0 degrees Celsius. We have already discussed about high temperature will lead to elimination. Of course, the correct option is A, that is room temperature and above this temperature. Room temperature generally considered standard room temperature is 25 degrees Celsius. So more than this room temperature, it will subject to undergo elimination reaction, thus forming this alkene. Clear? Okay. The next is hmm. In this case, this is the reaction and this is a product. Again, the example of elimination reaction, we have to identify the most efficient nucleophile. For elimination reaction, the most efficient nucleophile is the strongest base. The base which is more strongest, we have already discussed their pK value. So it's a 16 and its pK value is -7 when it is like this. And for here, methanol is this. Okay. So this is a strong base, CS3O negative. How we can say this is a strong base? It depends on its conjugate acids. If we add H positive to this reagent, what will be the product CS3OH? If we add H positive to its conjugate acid, sorry, we add H positive to this, then its conjugate acid will be CH3OH2 positive. And out of these, which is more strong? Which is more stable product? Methanol is more stable product than this protonated product. So that's why CH3O negative is the strongest base. So it will favor elimination reaction. So out of these, which is more strong base? CH3O negative is strong base as compared to CH3S negative. Why? Because here the oxygen has small size, okay, and the sulfur has large size. Small size, large size. The negatively charged is diffused on smaller area, but in case of sulfur, the negatively charged is highly diffused. It is not concentrated. So this O negative can attack easily, attacks as compared to S negative. So in this, electron density is more as compared to this base. So that's why methoxide is more strong base. So out of F negative and Cl negative, which is better nucleophile in aqueous media. So here condition is mentioned. We are using aqueous media. So what happened in aqueous media? If you are taking F negative in water and Cl negative in water. Okay, these are already present in the form of ionic form. Then the second step will be solvation. Solvation in this, the water molecules will surround this anion F negative with opposite charges. Then HOH positive. The H positive from water will interact with F negative. Similarly, another molecule will interact. Similarly, another molecule of water will also interact. So these are stabilizing this F negative, okay? But see, in case of Cl negative is also stabilized by the opposite charges from water molecule. H, no, but Cl has larger size as compared to the F negative. If fluorine has this size, F negative has this sign, but Cl has less negative. So Cl negative is less stabilized by water molecule. Clear? Because of large size of Cl negative as compared to F negative, the molecules will be at some more distance from Cl negative due to its large size. So there is less solvation in case of Cl negative. If this is less stabilized, it is free, there is no steric hindrance, so it can easily act as nucleophile. Clear? So F negative cannot act as nucleophile. So in aqueous media, Cl negative is better nucleophile than F negative. The next is identify the nucleophilicity and basicity of these two molecules. You have to tell which is more nucleophilic and which is more basic. Obviously, this first one is bulky nature, then this is more basic in nature. More basic in nature. And this is less bulky nature, so this is more nucleophilic. Okay. So next is the last one, which is a good base. We have already did it in previous questions. So methoxy is the good base and methanol is good nucleophile. This is good base. So we are done with the question. We have practiced a lot of questions based on only reagents. So in further session or further lecture, we will discuss about the nature of reactant and leaving group and polarity of solvent. How these all affects the elimination reaction, where how these tell the fate of reaction, whether E1, E1cB or E2 mechanism. So thank you. And if you need any kind of help, then please comment me. If is there any another question you can ask from me, and share and subscribe. Thank you.